So in this video we would be learning about the fundamental principle of addition. So this is a pretty straightforward principle, and let me first write the statement of it so that you could get a better understanding of what it actually means. So let's write the statement. So the fundamental principle of addition says that if there are n jobs, so if there are n number of jobs, let's name them J1, J2, J3 all up to Jn, that can be independently done in M1, M2, M3 all the way up to Mn ways, then number of ways of doing any one of the jobs, any one of the jobs is given by, let me change color, M1 plus M2 plus M3 dot 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 all the way up to Mn. So what it says is, whenever we have, say, n number of jobs, so we are having J1, J2, J3 all up to Jn, that can be independently. In my previous video as well I have explained the meaning of independent jobs. So this means that the number of ways of doing one job is not affecting or impacting the number of ways of doing another job. So these are independent in their sense, right? So if there are n jobs, J1, J2, J3 all up to Jn, that can be independently done in M1, M2, M3 up to Mn ways. So J1 could be done in M1 ways, J2 could be done in M2 ways, J3 could be done in M3 ways, all up to Jn could be done in Mn ways. Then the number of ways of doing any one, so the number of ways of doing either job 1 or job 2 or job 3 or blah 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 up to Jn is given by this whole expression, which is the sum of all the number of ways of doing individual jobs. So did you notice one thing? I said or. So by saying or, I mean that we are doing either job 1 or job 2 or job 3. We're not doing those things in simultaneously, as we did in fundamental principle of multiplication. In fundamental principle of multiplication, we did the jobs in succession, one after another, but in this we are doing either job 1 or job 2 or job 3 or blah 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 up to job n, right? So to make the thing more clear, I would like to give you an example. So let me type the example for you. So we have here this pretty straightforward question. So let's read it first. A librarian wants to select a book from 12 unique physics books, 10 unique chemistry books and 10 unique maths books. In how many ways can he select it? So it's very important to remember that this particular word unique over here is really important, because else there would have been just 3 ways of selecting a book. Either he could have chosen physics or chemistry or maths, right? Because all the books in physics or chemistry or maths would have been identical, so there would have been 3 ways. But as we are said that there are 12 unique physics books, so each and every book is unique in itself, and that's why these are separate cases, right? So he wants to select a book, there is one book out of all this. We have to find out the number of ways of doing so, right? So let me write the solution. So what are the possible jobs that this librarian could do? He could choose either a physics book or a chemistry book or a maths book, right? He could choose either a physics book or a chemistry book or a maths book. Did you notice I said or? So definitely there's something to do with fundamental principle of addition, right? So let me write down the jobs that he could perform. Let's first name the job of choosing a physics book. Let us name it as job A. And in how many ways could it be performed? It could be performed in 12 ways, right? There are 12 ways of choosing a physics book. Now let's name another job, which is job of choosing chemistry book. Let's name it as job B. And in how many ways could it be performed? It could be performed in 10 ways, right? So there are 10 unique chemistry books. Also, another job is job of choosing a maths book. Let's name it as job C. And in how many ways could it be performed? It could be performed in 10 ways, since there are 10 unique maths book, right? So now we can write over here that number of ways of choosing a book. So the librarian has to choose a single book, right? So we can write that number of ways of choosing a book. So here you should notice that these three jobs are independent of each other. Independent of each other. So the librarian could choose either a physics book or a chemistry book or a maths book. He could perform any of the particular job independently of each other. So if he chooses a chemistry book, it is not impacting any other job, right? So he is just willing to choose a book, and he can do it in 3 ways. He can either choose a physics book or a chemistry book or a maths book. So these are 3 independent jobs, and we have used the word or, right? He wants to perform any one of the 3 jobs. So by the fundamental principle of addition, we can say that number of ways of choosing a book is equals to number of ways of doing job A number of ways of doing job A plus number of ways of doing job B plus number of ways of doing job C, correct? This is according to the fundamental principle of addition. So what we can write, the answer is number of ways of doing job A is 12 plus number of ways of doing job B is 10 plus number of ways of doing job C is 10. So it comes out to be 32. So there are 32 ways in which the librarian could choose one book from the bundle of 12 unique physics books, 10 unique chemistry books, and 10 unique maths books, right? So there are total 32 ways. So the fundamental principle of addition, this is very handy whenever you have a pretty long and lengthy permutations and combination problem. So that's how we can use the fundamental principle of addition to take the independent cases separately and adding up number of ways to do those jobs to get total number of ways of doing it. So the jobs need to be independent and we have to do any one of that particular job at a time. That's when we use the fundamental principle of addition. So that's it in this video. In the next video, we would be learning about a very important thing in permutations, which is the permutation formula and the representation of it. So that's it for today. Thank you.